Okay, so my vertical asymptotes are x equals plus or minus 2. And what that tells me is that I have a function, well, I don't know what the function looks like yet, but I know that at 2 and at minus 2, I have these vertical lines that my function is approaching. And I have some information about how it's being approached too. Okay, when I approach negative 2 from the left, I go up to plus infinity, so it's doing something like this, maybe. And when I approach negative 2 from the right, I have minus infinity, so maybe it's doing something like this. Or it could be like this, I don't really know, but I just know that it's going down like that. Approaching 2, plus 2 from the left, I'm going down to minus infinity again, so it's like like that. And approaching plus 2 from the right, I'm going up to plus infinity, so I have like so. Okay, so this seems like a whole bunch of work, but I hope you agree I have some information gained about my graph. Okay, horizontal asymptotes. Ha. I'm doing two limits. Limit x goes to plus infinity of f of x, and also the limit as x goes to minus infinity of f of x. So that's limit of 1 over x squared minus 4. So I got an infinity downstairs, so I get 0. And here I get same thing, but minus infinity, but same result. Also get 0. So what does that tell me? Going back up to my guy in red over here. When I go to plus infinity, so when I'm going way over here, too far, when I go way over there, my function is approaching y equals 0. So it's approaching the x-axis. So my function is maybe doing something like this, or something like this. Oh, which one is it? Well, I can figure that out, can't I? Can I not? I believe I can. If you have a large x value, think about this number here. If I have a large x value, this red circle is positive, right? Which tells me that it's going to be this guy, not this guy. Okay, and x goes to minus infinity, the same thing is happening. X is going to minus infinity. The y values are positive and approaching 0. So I have to go, oops, I'm approaching the x-axis like this. Okay, so that's what these limits tell me. And just looking here, you can already see probably what's going on is you have something like this going on, just, I'm not sure yet, but that's what I'm thinking. So this is what we were talking about before, just intelligently connecting dots here. Okay, so we have the horizontal asymptotes. So horizontal asymptotes, that's y equals 0, the x-axis in both directions. As x goes to plus infinity, and also as x goes to minus infinity. Okay, E, intervals of increase and decrease. So what did we say the derivative was? The derivative is negative 2x. You know what? Let's just copy pasta here. going to be able to get that. Oh, I'm not. I'm sorry, my app is not helping me here. F prime of x is minus 2x over x squared minus 4 all squared. Double check that. Sorry, everybody. Sorry, everybody. Okay. Okay, intervals of increase and decrease. So I want to first find out what the critical numbers are. So f prime of x equals 0. That's one way to have a critical number. That can only happen if the numerator is 0. So we get x is equal to 0. But here, in this case, we also have to consider the possibility that f prime of x does not exist. That can happen when x is equal to plus or minus 2. But these are not critical numbers. Not CNs because plus or minus 2 is, these numbers are not in the domain. You'll recall that f of x is 1 over x squared minus 4. Okay, so to be a critical number, you have to be in the domain. These are not in the domain because they cause a division by 0 here. So these are not CNs. So my only CN is this one. Okay, so I do my number line, and I put my 0 there. Okay, a little curveball here. I'm also going to put my plus or minus 2. Okay, they're not critical numbers, but they are asymptotes. And concavity, no, intervals increase and decrease. Okay, my function can change from increasing to decreasing at an asymptote. If you think about it, you know, if you have an asymptote, let's say in red here, if you have a vertical asymptote, I could be increasing before and I could be decreasing after, right? Okay, so for that reason, I'm going to take my asymptotes and put them on my number line here. So it's worth emphasizing. Put asymptotes on these number lines. So I'm going to do it in part E here, and I'm also going to do it in part G. In part G2. Okay, so here's my number line, and there's my derivative up there. Okay, using test points, let's say I plug in -3. I'm going to get positive over positive, and that's positive, so increasing here. If I plug in -1, same situation. If I plug in +1, I get negative over positive. Notice how the denominator is always positive because of the squared here. That can help you save some time. So decreasing here. If I plug in 3, I'm going to have negative over positive, negative, so decreasing there. Okay, so here's my intervals of increase and decrease.